Hello! Today we're going to do Lesson 3-3, Proving Lines Are Parallel. This is really similar to what we did yesterday, which was 3-2, and what we did was using parallel lines to show that certain angle pairs were equal or supplementary. So today we're going to do the converse of everything that we did in 3-2, and we're going to use those same theorems but in converse to this time prove lines are parallel. So our lesson objective is to use the angles formed by a transversal to prove that two lines are parallel to each other. Our first theorem is the converse of the corresponding angles postulate. So you'll notice that we have a converse here. So this is the exact same thing that we did yesterday, except for it's the converse of it. So this says if corresponding angles are congruent, then the lines are parallel. So you are told that angle 1 is congruent to angle 2. Therefore, we know that M is parallel to N. Okay? We're going to skip this and come right back to it. We're going to be doing a construction. But before we do that, let's finish doing our theorems on the back side on page 58. And so this one is the converse, once again, converse of the alternate interior angle theorem. And it says if alternate interior angles are congruent, then lines are parallel. So we are told that angle 1 is congruent to angle 2. Since angle 1 and angle 2 are alternate interior angles, we know that M is parallel to N. Next, the converse of the alternate exterior angles theorem. So if we're told that angle 3 is congruent to angle 4, then we know that M is parallel to N. And lastly, the converse of the same side interior angles theorem. So if we know that measure of angle 5 plus measure of angle 6 equals 180, or if we're told that angle 5 and angle 6 are supplementary, then we know that M is parallel to N. Okay, so those are our three new ones. Now, what if, let's do an actual proof. Okay, so on page 59, you can go ahead and cross this out. Let's do an actual proof down here. If we have this right here, and we are told that angle 1, which is here, and angle 2, which is, actually let's do 1 and 2, which is here. So these are same side interior, and we're given that angle 1 is equal to 6x plus 18, and we're told that angle 2 is equal to, I should put measure of, there we go, measure of angle 2 is equal to 9x plus 12, and we're told that x equals 10. And we want to prove that the lines are parallel. Let's call this line R and call this line S. So we want to prove that R is parallel to S. So what we need to do is set up our proof. And you'll notice that this is going to be same side interior angles. So therefore, that's going to be the converse of the same side interior should prove that S and R are parallel. So first we're going to say our given. So measure of angle 1 equals 6x plus 18. Measure of angle 2 equals 9x plus 12. And x equals 10. So that's all given. So if we use substitution, oops, this should be 1. If we use substitution, we should be able to substitute 10 into those. So measure of angle 1 equals 6 times 10 plus 18. and measure of angle 2 is 9 times 10 plus 12. So if we simplify, we have measure of angle 1 equaling 6 times 10 is 60, and 60 plus 18 is 78 degrees, and the measure of angle 2 is 90 plus 12, so that's 102 degrees. So that's simplify. So then step 3 says that measure of angle 1 plus measure of angle 2 should equal 180 degrees, because 78 plus 102 equals 180. And our reason for that is we are just, this should be step 4, sorry. We are just adding terms together. Now you'll notice that that equals 180. So therefore, R is parallel to S, which is what we wanted to prove, because of the converse of same side interior angles. So I just proved that R and S are parallel because of the same side interior angles converse. Okay? So let's get back to doing the construction back on page 57. So the parallel postulate says through a point, and they call that point P, not on line L, so any line L, there is exactly one line parallel to L. So here we have our construction. So remember, constructions, you're only allowed to use a straight edge and a compass. So what we're going to do is we're going to draw a line, and we're going to call this line L. And we want to find a line that's parallel to L through a point. And we're going to pick a point somewhere out here and call this point P. So here's how we do our construction. What we are going to be constructing, and we're going to construct parallel lines. And we're going to be using the corresponding angles converse theorem. Okay, and so first step is to draw a line through that's intersecting with L through point P. So something like that. Okay, then I'm going to use my compass, and I'm going to open it up so that I have a little bit of space here. It doesn't really matter how big it is. And I'm going to draw an arc at the intersection of that line and line L. And then I'm going to pick up my compass, and I'm going to move it so that it is now at point P, and I'm going to do another arc. And so this arc has the same measure between here, this length here is the same as this length here. These two are equal in measure. That is equal to that. Then what we're going to do is we're going to measure how big the arc is. So I'm going to take my compass, and I need to open it up so that it is the same length of this arc going from that line down to line L. So right about there. And I'm going to use that measure to copy it up here, just like so. So that this arc here is the same measure as this arc here. So those two are congruent arcs. Now we just need to draw a line through point P and through this intersection here. Mine's a little bit off. Put it down there. So that this line is now parallel to this line here. They are parallel. And I know that they are parallel because the corresponding angles are congruent. So therefore, the lines are parallel by converse of corresponding angles. Okay? So the lines are parallel by the converse of the corresponding angles. So that is the construction of parallel lines. I highly suggest that you try doing this on your own without looking. And if you can't, re-watch this last part of the video until you're able to do this construction on your own without watching me do it. See if you can do it on your own, because this will come up on a quiz and a test. So make sure that you practice this one lots. Okay, that's the end of the lesson. Thanks for watching.